Today, after having the concept of theoretical distributions in case of for the case of discrete random variable, today we are moving on to the next part, that is the theoretical distribution for continuous random variable. Okay, and in this case of continuous random variable, we will be having three distributions. We need to cover out three distributions. So here we are. As we have covered in our previous classes, the theoretical distributions for the discrete random variable. Now we are moving on to the theoretical distribution for some continuous random variables. As we have learned in our previous classes that there are two types of random variables. One is discrete, another one is continuous. Okay. So for both the cases, we need to cover out the theoretical distributions. For discrete, we have done binomial, Poisson, multinomial distribution, and now we are moving on to the continuous random variable, where again we need to cover out three theoretical distribution: normal, uniform, and rectangular distribution, or exponential rather, you can say uniform or rectangular or exponential distribution. So three distributions are there for continuous random variable also. Among the three distributions, the distribution that we are going to learn today, that is the normal distribution, it is the most important part, not only for your examination, for your further studies also. Whenever you are going to deal with the distribution or with the probability or some theoretical problems, normal distribution will be required again and again, as it is a standard. As standard results will come out with this normal distribution, we have standard forms of theoretical results. So that's why this is a very important concept of theoretical distribution for the case of continuous random variable. So one by one we need to cover out. Then we are going to clear out the concepts what we are going to learn in the case of normal distribution, or else you can say how we are going to evaluate the probability in a particular problem which follows normal distribution. Okay, so let us have that. First, a continuous random variable capital X is there. It is said to have normal distribution with parameters small m and sigma square. It is said to have normal distribution with parameters small m and sigma square if it has the probability density function. Look over here, it is probability density function. As we are dealing with the continuous random variable, therefore here we are having PDF, that is probability density function. So if it satisfies probability density function, small f x equals to 1 by sigma root 2 pi e to the power of minus x minus f whole square by 2 sigma square. For all the values of x ranging from minus infinity to infinity. For all values of x ranging from minus infinity to infinity. So this is the PDF. If this will be the structure of PDF, then the distribution is a normal distribution, or the random variable is said to have a normal distribution with parameters small m and sigma square. Right? This is the generalized case of normal distribution. Now, next we are going to deal with standard normal. Actually, each and every problem whichever is there in your normal distribution, we need to transform the problem into its standard normal form. So how we are going to get that standard normal form, that we are going to learn next. Okay. So before moving on to that, the probability curve of normal distribution is known as the normal curve. It is normal curve. Okay. The curve is symmetrical. Look, this is our curve. This is our normal curve. Curve is symmetrical, bell-shaped, and extended infinitely on both sides. It is going up to minus infinity, going up to infinity. Nowhere it touches the x-axis. Okay, and the curve is symmetrical at the point x m equals to 0. Okay, symmetrical about the middle point, and it is of bell-shaped. Obviously, it shows that like that. Achha. Now the work is what? just now I have told you that whenever a random variable is normally distributed, we need to transform this variable into the another variable which is standard normal variable. Okay, that means standard normally distributed, because all the values of probability whichever be given to us or whichever is there in theoretical part or in theory, those values are all for standard normal distribution. Okay, so we are going to transform now the variable x to its standard normal form. So let us do that. How we can do it? If a random variable x is normally distributed with mean small m and standard deviation sigma, mean is small m, this mean small m is mean value, and standard deviation is sigma for this random variable x. Okay, then z equals to, then the transformation z equals to x minus m by sigma is called standard normal variable. This variable z is called standard normal variable. Okay, it has the probability density function as fz equals to 1 by root 2 pi e to the power of minus z square by 2. 1 by root 2 pi e to the power of minus z square by 2. Okay, so in this way we are transforming. Now what is this? This z is our standard normal variable, and corresponding to this z, what the PDF we are getting, that is fz, that is 1 by root 2 pi e to the power of minus z square by 2. Okay, so in this way we are going to transform the variable. Whenever the variable random variable x is given to you, you need to transform that random variable x standard normal form. Okay, are you all getting that? So next part, next some properties are written over there that we are going to prove it out in our further classes. The very first property that they are saying, for normal distribution, mean, median and mode all are equal. Mean, median and mode all are equal, right? As we have learned in Poisson distribution, mean and variance are equal. But this is a particular distribution which is normal distribution, for which mean, median, mode, all the things, that means all measures of central tendency are equal, and that is equals to small n. Okay, and for standard normal distribution, whichever we have taken over here in terms of z, for this standard normal distribution, the mean value will always be equals to 0, and the standard deviation value will always be equals to 1. So for standard normal distribution, mean small m equals to 0 and standard deviation equals to 1. Okay, so this is the standard normal distribution, or you can say the standard normal variable. Now next we are going to learn how we are going to tackle out the problems whenever is given to you, how we are going to find out the probabilities. There are some criteria, there are some rules, specific rules that we are going to follow up in standard normal distribution, or you can say normal distribution, to obtain the probability. Okay. Next, I am going to share, just have a look over this and then I'll make it clear on our whiteboard also. So the thing that they have said, that if we require to find the probability that z is what? Standard normal variate. That z variate lies between C and D. Probability that z variate lies between C and D, that is area under the standard normal curve between the vertical lines C and D. Okay, area under the standard normal curve between the vertical line C and D. What it is, let's see on our whiteboard. That in normal distribution, if we require to find the probability that C s equals to z less equals to d. If we require to obtain this probability where C and D are any two constant quantities, 1, 2, 3, 4, 5, 1.5, like this. Okay. So this area, this is nothing but area under the standard normal curve. So this is, if this is our standard normal curve, okay, it is symmetrical about the point 0, and say this is your C point and this is somewhere your D point. I require to obtain the probability that the standard normal variate. This is a Z. This is the Z axis. It's not Z axis. X axis denotes the values of Z over here. We'll take the values of Z over here. So probability that Z value lies between C and D. It will be given by area under the curve between the ordinates and C and D. Area under the curve between the ordinates at C and D. That means this area under the curve, whichever is given to you in your problem, this area will be the value of this required probability. Area under this curve between the ordinates at C and D is the value of the probability that Z lies between C and D. Okay. Achha, some more things that we are going to, that we need to learn over here. There is a concept phi Z. There is a concept phi Z. What does it signify? Again, this is the area under the standard normal curve. See, this axis is your straight line. I couldn't make the straight line like this. Okay, with the mouse. So whatever, this is our, say this be our Z point. Z can be any point, 1.5, 2, 3, 4.5, 4.75, like this. Whatever be the point is there at Z. What does phi Z signifies? Phi Z signifies the area under the standard normal curve, total area under the standard normal curve left to the ordinate at Z. This is our 0 point, Z equals to 0 point. Left to the ordinate at Z. That means the total left part of the ordinate, total area at the left part of the ordinate Z is representing phi Z. Is representing what? Phi Z. This is our phi Z. Okay. So phi Z is what? Area under the standard normal curve left to the ordinate at Z. Left to the ordinate at Z. Okay. Right. Now, can you tell me, if I have a standard normal curve like this, whatever the probabilities you require to find in normal distribution, they are nothing but some area under this standard normal curve. Now, can you tell me, what is the total area under this standard normal curve? Anyone?
1.
Oh, stop. You said it is 1. All right. Why it is so? Why you have said?
The largest probability, ma'am.
Largest probability value. Shaib. Oh, stop. Can you give me the answer? You said
Yes,
it is.
ma'am.
Yes. Follow.
Yes, it's the largest probability which we can get is
Yes.
1.
Because, yes, very good. Both of you are correct. What we are doing, area under the standard normal curve is nothing but representing some probabilities. Okay. All the probabilities that we are going to deal with in normal distribution, they are nothing but some area under the standard normal curve. Some area under the standard normal curve. Okay. So whenever you are representing the probabilities as area under the standard normal curve, that means the maximum probability value, that means the maximum area what it can take within this region, that is 1, because the maximum probability value we can take it as 1. More than 1, no probability value extend after 1. Okay, exceed 1. Okay, so maximum, since the maximum probability value is 1, so total area under this standard normal curve will be 1. Now can you tell me, if total area under this standard normal curve is 1, what about this part? What about this part? Both
1 by
sides.
2.
It is 0.5.
Half.
Yes, it is half. Okay. Since the curve is symmetric, at the point Z equals to 0, therefore this portion is half as well as this portion is also half. Okay. So this is the concept. And now, if you have this much concept, can you tell me what if I require to find phi of minus z, how can I got phi of minus z? Is it related anywhere to phi z? Say phi z is given and you
And
require to
the
find
coordinate will and we have to put the coordinate in the negative x-axis.
then it will be
Whatever we will
negative
get, we
x-axis.
have
Yes,
to phi
it
z.
is at minus z. Minus, if z is there, then minus z is at there. Okay, in the
Then it will be
negative
1
side.
minus phi of z.
1 minus phi of z. Very good, poster. Anyone else? Have you understand why phi z can be written as 1 minus phi? Phi of minus z can be written as 1 minus phi z. Anyone else? If you can explain me a little bit. A little bit explanation. If
Phi
I
minus
yes.
z, ma'am, phi minus z denotes the area on the left side of point O.
Yes.
That's why if phi of z, we can find phi of z, then the other half will be 1 minus phi of z.
Yes. Okay. Since for others I am saying, say this is our standard normal curve, right? It is symmetrical about the point 0. If this is your z point, I require to obtain phi of minus z. This is your minus z point as the curve is symmetry. Okay. Now phi of minus z represents what? Since phi of z signifies area under the standard normal curve left to the ordinate at this point z. Okay. So phi minus z means area which is left to the ordinate at minus z. That means this area we require to find out, right? This is our area phi of minus z. Are you all agreed with that? Are you all agreed with that? This is our area phi of minus z.
Yes, ma'am.
Okay. So now see, phi of minus z I can obtain in terms of phi z as 1 minus phi z. I am writing this as 1 minus phi z. How come? See, phi of minus z, this area will be equals to this area. Are you agree? Left hand side of minus z will be equal to right hand side of z. Are you all agree?
Yes, ma'am.
Why it is so? Because the total curve is symmetrical about the point 0. Okay. So that means if I can find this one, then the work is done for phi of minus z. Okay. And what about this one? This is nothing but total minus left hand side of z. Total minus left hand side of z, right? So total means total area is 1 minus left to the ordinate at z. What does it represent? This is our phi z. Okay. So in this way, phi of minus z will be 1 minus phi z. Is it understood by all?
Yes, ma'am.
Yes, ma'am.
In the problem, they have given to us the mean weight of 500 students. That means mean value are given. That is 151 pounds. And standard deviation of the weight is given. That is 15 pounds. Now, if the weights are normally distributed, find the number of students lying between the weight 120 and 155 pounds. So, what I need to do, very first, I need to take a random, select the random variable. I need to denote the random variable. What they have done is capital X to be a random variable which is denoting weight of the student in a certain college. Okay. And then if I can find the probability that the weight of this particular student lying between 120 and 155 pounds, probability that a particular student weight lying between 120 and 155 pounds, then how could I get the total number of students in this interval? How could I get the total number of students whose weight lying in this interval? If you can tell me. If I obtain the probability that a particular student weight lying between in this interval, then by unitary method, total number of students is given to you. How many students are there in total? That is 500. So that probability multiplied by 500 by unitary method gives you the total number of students whose weight lying between 120 and 155 pounds. So let us proceed like that. They have taken x to be a random variable which is normally distributed and which denotes the weight of a particular student. Okay. Next, that means now I require to obtain the probability that 120 less than equals to 8 strictly less than 155. That is the weight lying between probability that particular student's weight lying between 120 and 155 pounds. So now see, with x we cannot do anything. I need to transform the normal distribution to its standard normal form. That means I need to transform the variable x to the variable z form. Okay. And what is the transformation? As we have seen earlier also, that the transformation is z equals to x minus m by sigma, where m is the mean and sigma is the standard deviation. So let us do that. We'll do the transformation throughout. What is m given to you over here? 151. And standard deviation given to us as 15. Okay. So 120 minus 151 divided by 15. X minus again 151 divided by 15. 155 minus m, that is 151 divided by 15. Now evaluating this part, 120 minus 151 by 15, we are getting it as minus 2.07 less than equals to x minus m by sigma, means it is z, the variable z, and less than equals to this part, if we have evaluate, it will become 0.27. Okay. So now see the form we have got, that is probability C less than equals to Z less than equals to D. And what is given to you in your problem, some values are given to you in the form of phi. So if we are going to evaluate this probability in terms of phi, then it will be phi of 0.27 minus phi of 2.07. So phi of 0.27 minus phi of what it is? Phi of B means minus 2.07. That means actually this probability means what is required by us, that if this is 0.27 and this is minus 2.07, that means to obtain this probability means we need to obtain the area under this curve. Okay. Now that could be done in terms of phi, as the phi values are given to you. So phi of 0.27 is already given, that is 0.6064, that we can write directly over here. Achha. Phi of 0.27 signifies what? Phi of 0.27 minus phi of minus 2.07. Phi of minus z means 1 minus phi z. Okay, right? Now phi of 0.27 is given to you as 0.6064 minus 1 minus phi of 2.07, that is given to you as 0.9808. 0.9808. Okay, you can directly put on the values here. They have taken 0.5 plus. No need to do that. You can directly put on the values and you will be getting it as 0.6064 minus 1 plus 0.9808. And the value that we are getting for the probability is 0.5872. If this is the probability for one student, then total number of students lying in this criteria will be into 500. So this into 500 gives you 294 approximately, 293 point something I got, and it will be 294 approximately. So we will be having 294 students lying between this interval, whose weight lying between this interval. Okay, so this is the way how we are going to tackle out the problems in normal distribution. We need to have the concept of phi. Why? Because most of the cases and most of the problems, the values that is given to you, that is in terms of phi values for standard normal distribution. So we need to have the concept of phi z, and if we have that, we can tackle out the problem in this manner.